Hello everyone, welcome to Double Academy. Myself Vinay BK. So today we're going to solve one simple problem from question paper itself. Can call uh, tricky problem, but it is having only three steps to solve. You can see now what they are: potential difference between m and n. Potential difference between m and n using source transformation. So before that, I'll just give you some brief explanation about source transformation from voltage source to current source to voltage source. You can observe here there is a practical voltage source. Practical voltage source means the source along with the internal resistance R and V. So you can convert this voltage source into current source is nothing but, let's see now, minus to plus. The current is flowing from lower potential to higher potential, that is upward direction. So if you want to convert or else if you want to transform the source voltage into source current, the current source is in parallel with the same value of resistor like this R. And the direction of current is minus to plus, that is nothing but upward direction. Suppose if it is like this minus plus, in that case current is flowing in downward direction. Downward. So that like how like this you can do source transformation, just a basic technique. Now we'll apply this technique to this problem, but a quite tricky problem. So why I'm telling this as a tricky problem means you can observe they were connected one resistance in series with the current source. So always you know that resistances which is connected in series with the voltage source, not voltmeter. Similarly, a current source is always connected parallel to the resistor. That is nothing but practical current source and practical voltage source. But in this problem, they are given two current sources that will be connected in series with the resistors. 1 amperes with respect to 1 ohm. Similarly, 2 amperes with respect to 4 ohm. So in this kind, if suppose resistors are connected in series with a current source, you can call that resistance as redundant resistances, and we need to neglect that resistance. So now by neglecting these two redundant resistances, the circuit may look like this. So I'll rewrite again. There is a 15 ohm resistor or 15 ohm voltage source or 15 volts voltage source in series with a 3 ohm resistor, 15 volts in series with a 3 volts, and again the circuit will be like this: minus plus 2 ohm resistor. So these two resistors are going to neglect because this can call that as redundant resistances that is connected in series with a current source. Suppose if there is a resistances which are connected across voltage source whenever you are doing source transformation, in that case you have to neglect that resistances. For example, like this, if there is a voltage source, it has 15 volts source, and there is a resistor connected in parallel with a voltage source, say it has 2 ohm, and this combination is connected in series with some resistors along with another voltage source like this. In this case, you need to neglect this redundant resistance. Okay, so now we are applying that rule to this problem. So by applying that rule, so you can rewrite this circuit as like this: 1 ampere is flowing upward. Similarly, 2 amperes is flowing downward. 2 amperes. Then we'll be having 10 volts, 2 ohm. So it is very simple now. Reduce this network. So I'll rewrite again: 15 volts and 3 ohm practical voltage sources are transforming into current sources. then the circuit will be like this. What is the direction of current? Minus to plus. Minus is nothing but lower end, plus is nothing but upper end, like this. This current source is connected in parallel with the same value of resistance, that is 3 ohm resistor, and again we'll be having 1 amperes upward, then 2 amperes downward. Again you're converting this 10 volts 2 ohm into current sources. The circuit will be like this, 10 volts downward, so that downward current source is in parallel with the resistors, the same value of resistors, say that as some 2 ohm resistor. So written all, I just kept empty for two current sources, that is a transferred current sources. So this current I is given by V by R, whereas V is 15 volts, R is 3 ohm, 15 divided by 3 is nothing but 5 amperes of current is flowing here. Similarly, at the other voltage source here, 10 divided by 2, I is given by V by R, that is nothing but voltage is 10, R is 2, 10 by 2 is nothing but 5 amperes, so that 5 amperes is flowing downward. So now you know the rule that if the currents are flowing in the same direction, then there will be addition of current. If the currents are flowing in opposite direction, then there will be a subtraction of current. That is the difference of the current. See now, I can observe 1 amperes and 5 amperes are flowing upward direction. At the same time, 5 amperes and 2 amperes flowing in downward direction. So I'll rewrite this as, so 5 plus 1, 6 amperes flowing upward with respect to 3 ohm resistor. Similarly, 2 and 5 amperes are flowing in downward direction, so that 5 plus 2 is nothing but 7. Same direction means addition. 7 amperes is flowing downward with respect to 2 ohm resistors. So now we can observe 6 amperes is flowing upward, 7 is flowing downward. Which is having highest magnitude? The downward direction current source is having highest magnitude, so that 7 minus 6 current you can write 7 minus 6, that is nothing but 1 amperes, and the direction is downward because the highest magnitude is having downward direction. So that you can rewrite this circuit to get one current source. So right now 1 ampere is flowing downward because highest magnitude having downward direction, downward 1 amperes, and resistors 3 ohm and 2 ohm, they are connected across M and N. 3 ohm, 2 ohm. So now it is very simple. Two resistors are connected in parallel, so that you can rewrite 1 ampere downward with respect to equivalent resistance R equivalent across M and N. So this R equivalent is given by 3 into 2 divided by 3 plus 2. 6 by 5 is nothing but 1.2 ohms. So 1.2 ohm with respect to 1 amperes. So now we can convert this current source into practical voltage source. So practical voltage source means the voltage source is in series with a resistor across M and N. The resistor value is 1.2 ohms. V is given by I into R, whereas I is 1 ampere, R is 1.2, so that value of voltage source is also 1.2 volts downward direction, nothing but minus to plus, so that I can write minus plus here. So you can observe the conversion from starting. So earlier the circuit will be like this. So now you are neglecting the resistances which are connected in series with the current source, then 1 ampere is flowing upward, 2 ampere is flowing downward. Then you are converting voltage source into current sources, so that 5 amperes with respect to 3 ohm and 2 amperes, and 5 amperes with respect to 2 ohm on the right side. So I am rewriting as it is 1 ampere, 2 ampere. So now we can observe whatever the current which will be flowing in the same direction, that is addition of current. Whatever the current which flows opposite direction, then there will be a subtraction. So here two currents are flowing same direction, 5 amperes and 1 ampere, so that 6 amperes flowing upward. Similarly, 2 amperes, 5 amperes flowing downward, so that 5 plus 2, 7 amperes downward. Okay, so the rest of the resistors are step 3 and 2. Again 6 amperes flowing upward, 7 amperes flowing downward, but 7 amperes, that is highest magnitude current, is flowing in downward direction, so that 7 minus 6, 1 ampere is flowing downward with respect to 3 and 2. Then you are simplifying the resistances, parallel resistances, you can get 1 amperes, 1.2 ohm. Then converting that current source into voltage source, then you can get 1.2 volts with respect to 1.2 ohm resistors. So this is how we have to solve the problems related to source transformation. So this is quite a tricky problem. So try to analyze neatly and solve the problems like this. If resistances are connected in series with the current source, if the resistances are connected across the voltage source, you can call that as a redundant resistance. I hope you are understanding the video. Thank you one and all for watching the video. If you're having any doubts, please do write in the comment box and share as much as possible, and also subscribe to this channel. Thank you one and all. Have a nice day.